we're back. The goodest puppy is taken care of, and oh, sorry, one sec. Let me go check the smoke alarm. One sec. Okay, I'm back. Everything is okay. Nothing is wrong. There's no fire or anything. Just a low battery. Although, let me check. Where did I put my... Here's the multimeter. Let's take a look at the battery. Let's see what the voltage is coming back as. Okay, so DC voltage. So 8.27 volts. Yeah. So it's stable at that voltage. It's not dropping or anything as I'm measuring it. But that is low enough. 8.27 is low enough. The smoke alarm is not happy, so let's see. Do I have a 9? No. Okay, I just bought some. I just haven't put them in the case yet. Okay, I'm back. I promise this is all relevant, but, well, kind of relevant to where I was going with all of this. These are the 9-volt batteries of science. Okay, so the other ones were good until 2026. These ones are good until 2029. Okay. And what's the voltage on a fresh 9-volt battery of science? .55. So, a fresh 9-volt battery, this should be around 9.55, give or take. And a dead 9-volt battery, or at least dead enough that the fire alarm wasn't happy about it, is 8.27. 8.27 volts. Versus 9.55. Okay, so let's go put that in the fire alarm. And is this one 2029? Okay, and I'm back. Sorry about that. As much as I didn't want to be, or as much as I don't want to be the kind of person, or didn't want to be the kind of person who changes batteries on fire alarms during the middle of a live stream, I also didn't want to be the kind of person who takes batteries out of fire alarms and says, it's okay, I'll change it later during a live stream. So, I feel it's more responsible to change the battery when it starts beeping like that. Okay, so where was I? Let's finish the Python challenge. Okay, so the one thing here, I wanted to pull up the documentation for the Python list class. Because I have a feeling that we will need this right here, the count method. Yeah, that's, wait, why is banana returning 3? Banana. Oh, that's index, not count. Okay. Yes. Okay, count is what we want. So, I guess this is all new, so I'll read it off. I have some water. Your analysis only confirmed what everyone feared. The two lists of location IDs are indeed very different. Or are they? The historians can't agree on which group made the mistakes, or how to read most of the chief's handwriting. But in the commotion, you notice an interesting detail. A lot of the location IDs appear in both lists. Maybe the other numbers aren't location IDs at all, but rather misinterpreted handwriting. This time, you'll need to figure out exactly how often each number from the left list appears in the right list. Calculate a total similarity score by adding up each number in the left list after multiplying it by the number of times that number appears in the right list. Here are the same example lists again. Okay, so those are the same examples as before, but this time we're going through the left list. We're mainly focused on iterating through the left list and checking to see, or multiplying the value. Wait, is it the value? Yes. Oh, that's going to be pretty large because those are like five-digit values. That said, the repetition might be kind of low, so it might be like, 5 digits times like 2 or 3. That's not going to be too huge. Then again, maybe it is supposed to end up with a very, very large number. Who knows? But I think that seems like the right interpretation. I think we're only applying it. Yeah, we're only applying those operations to the left side. And checking the frequency on the right against the right list. Okay. So let's give that a try. There we go. Okay. So it's still 1,000 elements. So we're going to iterate over. Oh, hang on. Let's clear. Yeah, let's start by clearing some. Also reset n. Actually, we don't even need n. Instead Instead of using a while loop, yeah, I could just do here, use n for that. Okay, so for each value in list 1, store it in n. And then we want to take n. So let's do sum equals n times actually no, let's do this as separate steps just in case, because I feel like that is just asking for a bug somewhere in there. I could probably simplify it down into a nice little concise one-liner, but we're not trying to do code golf right now. We're trying to find something that works. Okay, so where was I? Sorry, for n in list. They call it the similarity score. Yeah. So we take the value of n times the number of times n occurs in list 2. That's our similarity. Let's print that out just to see if it's working. So let's say n equals %sign d. %sign d is for integers. And we don't really care about the whole list 2. We just care about what the value on list 1 is. We do want to know what the similarity is. Okay, so I should print the value of n and the similarity. And then we want to add that yes. Oh, right, because list is a list of strings. Okay, one sec. We can fix that with an int conversion. Okay. We're still fine there. Yeah, it's n that needs to be cast in the next page, or the next line. Should fix it. Is it treating it like a string here? It might be. We still want it to be a string here, because we're checking the number of recurrences of that string. So list 2 is also going to be strings of numbers. But this we probably want to convert, because I guess it might be, yeah, it might be taking the strings and repeating them multiple times. Actually, an easy way to check, easy way to test that theory. Let's just try rerunning it. Oh, we need to set sum to, hang on. Sum equals 0. Let's also set n. We overwrite it right away, but just to be safe. Okay, so for n in list 1, similarity equals int of n. There we go. Oh wait, I was gonna. Okay, well now this should work as is. I was gonna change it so that it was strings to check and see if it was still. Okay, well either one would have worked. If I hadn't changed them over to ints. Yeah, let's just do it this way. There we go. Let's check and see if that's the right answer. 23117829. Yay! Alright, so that's part 2, I guess. That here, let's just finish up any. So now that we know that we got it right, well, that's good. Say it with the code. Okay, yeah, so I wanted to try rerunning this just to test the theory that I had. So let's not convert that to int. Let's just change this to string. Yeah, sum is probably going to be meaningless. But the important part is it should print out n and the similarity value, and I'm thinking the similarity is probably going to be the number repeated. But let's see. Oh, it didn't like the sum and similarity, so I should have actually taken that line out. Damn it. Okay, let's just reset this. sum. So let's just run that. Yeah, there we go. 99781, 99781. Yeah. So if I don't convert it to an int, what it was doing before is it was setting the similarity to be this really, really long string of numbers. So I had to convert n, not at this stage, but here. Because, I mean, I could have also converted it earlier when I was building the list in the first place. Right after I split them would have been a good time to do that. Right after trimming spaces off of the end and splitting it on the 3 spaces in the middle. I could have also taken the numbers that it had just split it off into, I think val 1 and val 2, and I could have, that would have been a good time to convert them to integers, and then build the list, and then I wouldn't have to do this later on, but I wasn't thinking of that at the time, so, oh well, we got the answer. Sometimes you have to, if things aren't in the format you want when you go to use them, you just convert them. That's one of the things Python is very good at, is just converting things on the fly. But if I were to take this and rewrite it as like a function that I wanted to rerun and put in, say, a Python file and make it reusable, that would probably be a good time to go and change it so that, well, there's no reason to build that data structure out of strings. That's actually a prime candidate for converting it from, or parsing it from a string of numbers into separate integers, because as integers they'll take less space in memory. So a list of integers will take less memory than a list of strings, and will also be easier to work with later on down the road if what we care about is the numbers, which is what we care about. So, but we can always go back and change that when we want to make an actual. Like right now, it worked well enough for testing. It got the solution. It got the problem. It solved the problem that we were trying to solve. And so that's good enough. And I'm going to call it there. And I don't know, maybe we'll grab the code from the terminal and clean it up or something. But I think we're going to call it there. And I'm going to go to bed. So have a good night. And we'll try the next challenge. See you tomorrow. Bye.